Okay, coefficient of variation. Now here's that problem with the miles per gallon in the cars. And we decided probably on the average this car A would be better because it gets a higher, miles per gallon. So that was better on the average. So we figured out the mean. And we're like, okay, I'm going for car A. All right, we didn't figure out the standard deviation. Should I still buy car A? I don't know. What is that standard deviation to help me? Okay, coefficient of variation. It's a measure of how wildly it's swinging. I mean, these numbers, the standard deviations, kind of tell me something about how big and apart these numbers could be. I mean, the range here is like 6, and the range here is only 2. But this is just a kind of way of measuring it as a percent. Okay, so you put the standard deviation on the top. Is this right? You put standard deviation on the top, and the mean on the bottom, and that's going to give you a decimal. 0.08557. They love that as percent, so that times 100 is just to turn it into a percent. 8.57%. 1.095 divided by 28.2 is 0.0388, 3.88%. I mean, I still don't know which car to buy. It's kind of up to you. But car A could be anywhere. You could be planning a whole trip, and it turns out you got a lot of these really, poor performances, and it's just all over the place. Okay, you can't really predict. And this one is a little bit tighter. You can predict a little bit better. Those numbers don't go too far. This one's got a big range, that one's got a little range. Okay, you might still purchase that one because on the average it'll probably come out better. But it's just another way of checking things. Okay, so now here I'm looking at these. Well, gosh, this swings from like 30 down to 10. That's a range of 20. And this is just 3 down to 1. That's a range of 2. But if I go ahead and do this, X bar is 15, SX, X bar down here is 1.5. Not too surprising, all I did was took the 0 off the end of all those. Okay. 8.37, I'll call it. And down here, 0.8337. All right, so CV is 8.37 divided by 15, which is 55.7%. Which, first of all, those numbers are fluctuating wildly. If there's like a variation of like 50%, 0.837 divided by 1.5 comes out to be exactly the same percent, 55.7. That's bizarre. They're not even the same numbers. The range is totally different. How does it come out that way? It's because, as a proportion of the whole, 3 is far away from 1, the same way 30 is far away from 10. But these numbers are all bigger to start with. That's how they end up with that canceling out somewhat in there. 30 being away from 10 is just about like 3 being away from 1, because as a percent of what you got, it's really bad.